The problem that I'm going to be doing is 2004 AB question number 1. All the information is provided in the question, so let's go and explain each piece of the answer. First step, A. To find the area, let's look at what the graph sort of looks like. You have it coming off of at x equals 1. It is going to be cut off at x equals 10. By plugging 10 into the function x minus 1, we realize that the height of this object is going to be at 3. It will have started at 0. The reason I'm marking all the values is that we're going to do this problem not only using a dx, but we'll also do it as a dy. So I'm going to make two versions of exactly the same looking graph. Again, 0 to 3 for the y's, 1 to 10 for the x's. Therefore, the area as a dx problem would, because you're making strips starting at 1 and stacking infinitesimally thin strips up to 10, your upper equation is radical x minus 1, which then you would subtract by going 0, which is your lower, and it'd be dx. So the integral, now before going further, let's remember this is a calculator question. Therefore, you may use f and int or any other feature of the calculator. However, since I'm always constantly looking at a way of practicing different skills, we'll do u substitution. We'll say u equals x minus 1. We'll say du equals dx. We'll figure out a table of converted x and u values. So if you're going from 1 to 10, now we'll go from 0 to 9. And what that would leave you with is the area will be computed by the integral from 0 to 9 of u to the half du. Taking the antiderivative, 2/3 u to the 3/2, going from 3/2 going from 0 to 9. Just try that again. 2/3 u to the 3/2 going from 0 to 9. Tricks that I want you to remember to make your life easier is that if you have 9 to the 3/2, that means 9 can be to the half, which is cubed. Since square root of 9 is 9 to the half, that just means 3 cubed, which is 27. So what you have is 27 minus 0, which works out to be exactly 18 units squared, whatever the units will be. If this is that was a dx, if this is a dy problem, think of your strips being stacked this way, which means when I compute the area, I'm going to have it go from 0 to 3. And I think of outer and inner, because 10 is always going to be the largest piece. Then I need to figure out what the distance is from here to there. Well, since y equals the square root of x minus 1, and this distance is x, I guess what I'll need to do is square both sides, add 1, and now instead of saying the distance of this is x, I can say the distance of this is going to be y squared plus 1. So that's what I'll subtract, y squared plus 1, and then go with dy problem. If you want to make this a little easier, just say it's from 0 to 3 of 9 minus y squared dy. Its antiderivative will be 9y minus 1/3 y cubed, going from 0 to 3. That's 9 times 3 minus 1/3 times 3 cubed, minus what is going to all be, for the most part, 0. And that's 27 minus 27 thirds, which is 9, which works out to be 18 units squared. In both cases, using the dx or the dy, the problem works out to be the same thing.